Hi everyone, I welcome all of you in this lecture. So in this lecture we will discuss another example which is related to this multiplication by t property. In previous lectures we have already discussed about its definition and corresponding formula and 4 examples. So in this lecture we will solve this example. So this example is to find the value of this Laplace transformation, that is Laplace of t into e raised to t into sin square 3t is equal to question mark. Okay. फर्स्ट काम काय आपलं की हे क्वेश्चन आहे तो रेकग्नाइज करायचं देन हा कोणत्या टाईपमध्ये आहे. सो दिस इज ऑफ द टाईप टी इन टू दिस फंक्शन दॅट दिस फंक्शन इज ऑफ द फॉर्म एफ ऑफ टी. सो वी विल सॉल्व दिस थेरम बाय one formula, that is when we have function like this, that is Laplace of t into f of t, this is our actually formula, then we can write our function, our Laplace transformation as minus 1 raised to 1, because here t has a power 1, therefore minus 1 will contain power 1, d by ds. Okay, similarly d by ds also contain a power 1 because t has a power 1, therefore d by ds will contain a power 1, and apply Laplace on this f of t, that is L of ft. This is our first formula. We will use this formula to solve this example. Okay, so here we have a function that is a sin square 3t. When we apply Laplace on this sin square 3t, but we don't have any standard formula for this sin square 3t. We have a formula for Laplace of sin 3t, but we don't have a formula for sin square 3t. Therefore we will convert this order 2 into linearity form. That is why we will use another formula, that is sin square theta can also be written as like this, that is 1 minus cos 2 theta divided by 2. Okay, so this is our first formula and this is our second formula, and we will use another formula, that is a first shifting theorem, because we have a function that is e raised to t. Then first shifting theorem says when we have a function, that is if Laplace of f of t is equal to some function phi of s, that is when we apply Laplace on function of t, then function f will convert into new function, that is a phi, and t will convert into new variable, that is s. Whenever this will happen, then we will get, that is Laplace of something e raised to at into some function f of t. Then we will have value, that is f will give us new function, that is a phi, t will convert into s. Here t contains positive sign, therefore we will write it's a negative sign, that is opposite sign, therefore subtraction, and t has a coefficient a, therefore write it as it is. Okay, so after solving this transformation, that is this Laplace transformation, then we will get this value. Okay, so by using these three formulas we will solve this example very easily. Firstly, we will do one thing, that is firstly we will use this second formula to reduce it into linear form. Therefore my step number 1 will be, that is step number 1, apply Laplace on my sin square 3t, but we don't have any standard formula for square term, therefore we will convert it into linear form. So for that purpose we will use this form here, that is Laplace of, in formula we have a theta and now we have a 3t. Now with the help of this we can write this RHS as 1 minus cos of 2 into theta, that is 2 into this term, that is a 6t, divide by this 2, that is 2. Okay, so now we can separate this Laplace transformation with the help of linearity property. Then we will have this Laplace, that is 1 by 2, we will take it as outside, then apply Laplace on my first term, that is Laplace of 1, then take minus sign as it is. This 1 by 2 is common for both the Laplace transformation. Okay, now secondly apply Laplace on my second function, that is Laplace of cos 6t. Okay, in previous lectures we have already discussed about this standard formula, that is take this 1 by 2 as it is, Laplace of 1 is equal to how much, 1 by s, take this minus sign as it is, that is minus, then apply Laplace on my cos 6t, that is its a standard formula says whenever we have a cos 80, then apply Laplace on cos 80, then it will give us value s divided by s square plus a square, but a is equal to how much here? 6, therefore 6 square, that is a 36. Okay, so these are two Laplace transformation, and with the help of standard formulae we have obtained the value of these two Laplace transformation. So our step number 1 is done here, that is, this is a strictly function in s variable, so we will denote as equation number 1. Okay, so apply example check करूया. We have obtained the value of this function, that is when we apply Laplace on the second term, that is sin square 3t, we have obtained this value, and we will denote this as equation number 1. Okay, now we have another function, that is t into e raised to t into sin square 3t. So in step number 2 we will consider this e raised to t into sin square 3t. Okay, so for that purpose my step number 2 will be apply Laplace on e raised to t into sin square 3t. Now to obtain the value of this function we will use this first shifting theorem, that is when we have a Laplace of f of t is equal to some function of a s variable, then whenever we have a Laplace of like this function, that is e raised to at into f of t, then we can write it as a phi of s minus a. Okay, so observe one thing, here we have a e raised to at, now we have a e raised to t. Okay, a is equal to 1 here, again f of t is equal to how much? Sin square 3t, and Laplace of f of t will be in variable s, that is a function of s only. So we have obtained in step number 1 value of Laplace of sin square 3t, that is a f of t. So that value is this, and this is nothing but our phi of s. Okay, so we have now Laplace of this function. Now we will use only this property here. So that property, that is by first shifting theorem, we can say when we apply Laplace on this function will convert into phi. Okay, now t will convert into which function? That is s variable. Here t contains a positive sign, therefore write it's a negative sign, that is a opposite sign, that is a subtraction, and t has a coefficient 1, therefore write that coefficient 1 as it is. Okay, so with the help of this property, this L of ft, that means this L of sin square 3t is equal to how much? Phi of s, that phi of s is equal to this. So when we have this function as a phi of s, and when we try to find this value, that is phi of s minus 1, just replace s by s minus 1 in equation number 1, then we will get that, take this 1 by 2 as it is, that is 1 by 2, then 1 by s, that is 1 upon s will be replaced by s minus 1, that is s minus 1, minus s will replace by s minus 1, divide by s minus 1 its square plus 36. Okay, so we have obtained our second multiplication, that is this, that is e raised to t into sin square 3t. We have obtained the value of this function. Now in step number 3, that is our last step, that is we will apply now Laplace of t into this second function. Therefore our step number 3 is, that is step 3, Laplace apply on t into my second function, that is this function e raised to t into sin square 3t. Okay, to find the value of this Laplace transformation we will use this formula, that is effect of a multiplication by t on a Laplace transformation. T has a power 1, therefore this term will contain a power 1, and then we will apply Laplace on this t variable, that is Laplace of f of t. In same way we can create this formula, t has a power 1, therefore minus 1 will contain a power 1. Again d by ds, that is d by ds, this will also contain a power 1. Okay, and when we apply Laplace on my second function, that is this is my second function, that is Laplace of my e raised to t into sin square 3t. Okay, so take this minus 1 raised to 1 is equal to how much? Minus 1. Okay, d by ds raised to 1, that means d by ds, and we have obtained the value of this Laplace transformation in step number 2, and that value is this. Okay, just to put this value here as it is, that is 1 by 2, take it as it is. First function will be 1 upon s minus 1 minus s minus 1 divided by s minus 1 its square plus 36. This is my second value. Okay, take this 1 by 2 outside from this derivative, that is minus 1 by 2, and apply derivative on these two terms, because algebra property is satisfied by with respect to derivative property. Therefore my first term will be d by ds of this 1 divided by s minus 1. Okay, this minus sign we will take it as it is, and d by ds of my second term is s minus 1 divided by s minus 1 its square plus 36. Okay, so this will be my second function. Now to find the value of these two derivatives, we will use its corresponding formulas. For this we will use this formula, that is when we have a d by dx into 1 by x, then its a derivative will be minus 1 by x square into this derivative of this denominator, that is 1. Okay, so take this 1 by 2, that is minus 1 by 2 as it is. Okay, and this is nothing but a minus 1 divided by s minus 1 its square into derivative of this term with respect to s, that is s has a derivative with respect to s 1, minus 1 has any constant term with respect to its derivative, of course it will give us answer 0. Okay, so we have done this part. Take this minus sign as it is, and to solve this derivative we will use this formula, that is quotient formula. When we have a d by dx into, that is u by v function, then that will give us value. Take denominator as it is and take its numerator's derivative, minus take numerator, that is u as it is, and derivative of denominator divide by this v square. Okay, denominator it's a square. So with the help of this formula we will solve this example, that is just take this denominator as it is, that is s minus 1 its square plus 36. Okay, now derivative of my numerator, that is s minus 1 its derivative with respect to s will give us answer 1, that is this into 1. Okay, now take minus as it is sign. Now you will take, I will take s as it is, that is s minus 1, that is numerator we will take it as it is. Derivative of my denominator, this will give us answer 0 because this is a constant function. Now derivative of this function is nothing but a 2 into s minus 1 raised to 2 minus 1 is 1. Okay, and derivative of this inside function is 1, so into 1, and divide by this denominator its a square, that is s minus 1 its a square plus 36 its a whole square. Okay, so we have obtained this value with the help of this formula. Now solve just little bit, that is this is my minus 1 by 2, we will take it as it is. My first term will be this 1 into this minus 1, that is minus 1 divided by s minus 1 its square. Okay, we have done this part. Now take this minus sign as it is, minus. My first term will be this, that is s minus 1 its square plus 36 into 1, that means this original term, that is this is my first term. Take this minus sign as it is, that is minus this 2, that is a 2, s minus 1 into s minus 1, that is a s minus 1 its a square. So s minus 1 its a square into 1 is into 1. Okay, divide by this my total term, that is s minus 1 its a square plus 36 its a square, and we have obtained the value of our main function, that is the value of Laplace of t into e raised to t into sine square 3t, and the value of this Laplace transformation is this. Thank you. Please like, subscribe and share.